Hi everyone. Today we are going to study about the light, and this chapter is from grade 10 Cbse. Now let's understand what is reflection. Now this is the main part of light. If we have to understand this chapter, so it's very important that these terms are very clear to you. So what is reflection? Reflection is basically the phenomena where light rays they return to the same medium upon striking a surface, and it is known as reflection. So basically reflection is bouncing back of light. Now there are certain laws which we have to remember, like the first law of reflection, which you have studied in previous grades as well. This talks about the incident ray, the reflected ray, and the normal to the surface at the point of incidence. And the second law of reflection tells us that the angle of incidence is equal to the angle of reflection, what you can see it on the screen. Now the angle which is making between the incident ray and the normal, it is equal to the angle between the reflected ray and the normal. So you can see this ray, incident ray, the red color line, that's the incident ray, which is falling on the smooth surface, and it's reflected ray which is reflecting back from the smooth surface. So these laws of reflections are basically applicable to the reflection of light from any smooth surface. So you are not going to be mistaken that it's only the mirror part, but any smooth or shining surface. Certain properties which you have to remember of image formed by a plane mirror. Now the first one is that an image formed by a plane mirror is virtual and erect. Second is the image is laterally inverted. Third is the image formed is as far behind the mirror as the object is in front of it. Now the size of the image, which is very important point, the size of the image is equal to that of the object. So these points are very important, which is even asked in exams. Okay, the next most important topic is the spherical mirrors. Now, the mirrors whose reflecting surface are spherical in part of a hollow sphere of a glass. So there are two types which you have to remember, of different two types of mirror. That's concave mirror is a curved mirror where the reflecting surface is on the inner side. So you have to remember on which side we are talking about. That's the inner side. And then the convex mirror is a curved mirror where the reflecting surface bulges out toward the light source. So if you see the concave mirror whose reflecting surface is curved, where it's inwards. And what about the convex mirror? Here the reflecting surface is curved towards outwards, or it is called a convex mirror. Now the certain terms which you need to remember, which is used in spherical mirror, that is pole. Now what is pole? Now if you see the figure here, there are certain terms being labeled. The center of a spherical mirror's reflecting surface, it coincides with the mirror surface itself. So you can see the center point here, pole, which is marked. So we denote the mirror's pole with the letter P, capital P. Second is the center of curvature. Now a spherical mirror has a curved surface from a sphere. The center of that sphere, if you can see it on the screen, it is the center of curvature. That means in concave mirror, it is in front, and in convex mirror, it is behind, right? Likewise, we have the radius of curvature. Now the radius of curvature is from which the reflecting surface of the spherical mirror is derived, and we symbolized it by the letter R. Some more terms which we have to learn it, that is principal axis. Now what principal axis is, if you have seen the previous slide, it is about a straight line that extends through the mirror's pole and its center of curvature. And this axis, what we are talking about, the principal axis, it is perpendicular to the mirror surface at its pole. Next we have our principal focus. Parallel rays, they meet at the principal focus, which is F, denoted by letter F for a concave mirror, and seem to diverge from the principal focus for a convex mirror. So the distance between the mirror center and the principal focus is the focal length, which is very important. So you will be doing some of the numericals related to focal length and the radius of curvature. Now, what is aperture? It's a very common term which is used, but you need to remember this as well, that the reflecting surface diameter in a spherical mirror is called the aperture. Now, when the aperture is much smaller than the radius of curvature, so we use this approximation, that is R is equal to 2F. Certain ray diagrams rules which you have to remember. First one, let's look at the first one. A parallel ray will either pass through or appear to converge at the principal focus for a concave mirror and appear to diverge from the principal focus for a convex mirror. So here we find for the concave mirror it is converging, and for the convex it is diverging. Now, second point, a ray directed at the principal focus of a concave mirror or passing through the principal focus of a convex mirror will come out parallel to the principal axis. So these two diagrams are equally important. We have more to understand in detail the concept about the ray diagrams. A ray passing through the center of curvature of a concave mirror, or it is directed toward the center of curvature. So if you can see it on the screen, the red line, and of a convex mirror will be reflected back along its original path. So what is the basic role of the rays here? That they are reflecting back along the same path. Point number 4. A ray which is incident obliquely to the principal axis towards the pole of the concave mirror on a convex mirror is also reflected back. So you can see it in the diagram. For the concave mirror, it's in front of it, and for the convex mirror, it's behind the focal length. Now, very important part which is extremely important for the students, which they have to remember and they tend to confuse in certain areas. So that's about image formation by convex mirror. Now, if you can see it on the screen, where is the object? At the first point, if you see, object is at infinity, and the position of the image will be at focus, which is behind the mirror. And what will be the size of the image? That will be highly diminished and not pointed in size. And what will be the nature? Nature, if you see, that is virtual and erect. The second diagram, it's now where is the image here? Where is the object here? It is between infinity and the pole of the mirror. So where is the position of the image? It is between P and F. And size of the image will be highly, or it's diminished, and the nature of the image will be virtual and erect. Likewise, if you see it on the screen, you will find how the position of the object, first it was at infinity, then it is beyond the center of curvature, then it is at the center of the curvature, then it is between the focus and the center of the curvature, then it is at the principal focus, and then between the pole and the principal focus. So what point you have to remember, that where is the position of the object and where is the image formation and what is the nature of the image. So students, this is extremely important. You just cannot neglect any single point. So each and every point is important. You can note it down, you can write it down, and likewise you can remember all these points. So these are equally important for your exams. Now, very important is the uses of spherical mirrors. Now, if you see here, concave mirrors, they are used in torches, headlights, shaving mirrors, dental examinations, and solar furnaces for heat. Okay, so we have convex mirrors. They are used in vehicles. They are rear view mirrors to provide smaller but upright images and a wider field of view, which enhances the driver visibility. Now comes the real part of the chapter where you have to understand the sign conventions, which you'll be using it for the numericals. Now for the sign convention, if you see, it's also important that if you know some idea for the coordinate geometry from your maths, that will make more sense to you, the terms which we are using here. Now for the first point, if you see in sign convention, it is object on the left, so light comes from the left. Now if you start measuring from the mirror's pole, that's the second point, If your third point, if you see, left is means negative and the right is positive. So in the positive side, if we are talking about, if I can mark it here, that is positive and this side will be negative, that is left side. Then above the principal axis, it is positive and below the principal axis is negative. Now, what important points which you have to remember? You can even jot it down and draw the diagram. That will make more sense to you. The object distance is denoted by letter U, which is always negative. Second point, the image distance V is positive if the image is formed behind a concave mirror, and it is negative if the image is formed in front of the mirror. Third point you have to remember, the image distance denoted by letter V is always positive for which mirror? For a convex mirror. The focal length of a concave mirror is always negative, and for that of a convex mirror it is always positive. The height of an object is always positive. Please remember this. And the last point, if the image is erect, the height is taken as positive, and if the image is inverted, the height is taken as negative. So students, it's a request that you draw this diagram and note down all these points. So that will be helpful to you. Now we have a mirror formula. Now mirror formula is about 1 upon f is equal to 1 upon v plus 1 upon u. The distance of the object from its pole. Again, I'm repeating this. The distance of the object from where? From its pole. It is called object distance. As we seen in the previous slide, it is denoted by letter U. When we are talking about the image distance, it is denoted by letter V. The distance of the principal focus from the pole, it is called focal length, denoted by letter F. Second point or topic, basically, it is about magnification. Now, magnification is produced by a spherical mirror, gives the relative extent to which the image of an object is magnified. So, the formula here, if you see, magnification, that is minus V upon U. So, virtual plus erect. If you see the positive one, for the magnification, positive, that is virtual plus erect, and if it is negative, it is real plus inverted. So this is the most easy way to explain so that you will not forget when we are talking about the magnification. And if it is between 0 and 1, so it is diminished, and if its m is equal to 1, that is magnification which is equal to 1, that will be same size, and if it is greater than 1, that is enlarged. Okay. The next point is about the refraction. That is the change in the path of a light ray as it passes from one medium to another medium, which is called refraction of light. So basically, refraction of light, it is the bending of the light. Okay. Now, if you see the first diagram here, the light rays, they undergo refraction by bending toward the normal. So normal is what? That's the perpendicular line which is on the surface. It is bending towards the normal when they transition from a rarer to denser. Likewise, on the other diagram, if you see, it is bending away from the normal. But bending of light, you have to remember, that is refraction. So in the first one, if you see that it is from rarer to denser, which is going where? Towards the normal. And when it is going from denser to the rarer, it is bending away from the normal. So these points you have to remember. Now the laws of refraction, as we have done about the laws of reflection, it's somewhere down, also very much similar to that, but again we can repeat it. The incident ray, the reflected ray, and the normal to the surface of separation of two media at the same point of incident, and they all lie in the same plane. Next is Snell's law. Now the ratio of sine of angle of incidence to the sine of angle of refraction for a light or of a given color, it is constant. So here the term which is used, the symbol which is used exactly, that is sine I upon sine r is equal to mu. So mu is the symbol which is termed as refractive index, and it is constant. Refraction through a rectangular glass slab. So here we have taken a glass slab. This experiment also can be done in the physics lab. Now, if you see the rectangular glass slab, I is the incident ray, R is the reflected ray, and E is the emergent ray, which you can see here. This is the emergent ray which is coming out. Angle of incidence is equal to angle of emergence. Please remember this on the screen if you see the diagram there. So angle of incidence, that is this one, angle of incidence is equal to angle of emergence. When a ray of light is incident perpendicularly on a plain glass slab, it passes through undeviated. So in this case, the angle of incidence is 0, and therefore the angle of refraction will also be 0. Now, what is refractive index? Students, they mostly have a doubt in this topic, so we are going to study this in detail. The refractive index, they measures how light changes direction when it moves from air to another material. It shows how fast or slow light travels and bends in different substances, helping us to understand its behavior. So refractive index of medium 2 to medium 1, which is equal to speed of light in medium 1 divided by speed of light in medium 2. And vice versa, if you take the other way, refractive index of medium 1 with respect to medium 2, then we are going to take speed of light in medium 1 divided by speed of light in medium 2. Okay, now we study about absolute refractive index. Now, this is the refractive index of a substance which is compared to a vacuum. The refractive index of water is 1.33, which means that light travels about 1.33 times slower in water compared to its speed in air. Now the formula, if you see it on the screen, that is refractive index, which is equal to C upon V. Now what is C here? That is speed of light in vacuum and air, and V is speed of light in medium. Let's quickly do one question. Now here you have to find the calculate the angle of incidence. Now how to calculate the angle of incidence and what is given? If you read the question again, calculate the angle of incidence of the light ray incident on a surface of a plastic slab of refractive index √3 if the angle of refraction is 30 degrees. So here if you see there are certain trigonometric values. Students, you have in grade 10 chapter trigonometry where you will be getting all these values. There is a particular chart and how to calculate these values, and very soon I will be putting the video related to trigonometry. Now coming back to the question. What is given? Light is traveling from air medium to the plastic slab. The angle of refraction is 30 degrees. Refractive index of the slab is N2, which is √3. Refractive index of air, that is 1. The angle of incidence, which we have to calculate. So which formula we are going to use here? Looking at the values given, we use Snell's law. Now what is Snell's law? It is sin I upon sin R. So we use this formula N1 sin I is equal to N2 sin R, and taking the sin I as the subject, and you calculate and you get sin I is equal to sin 60. So here what we do, we cancel sine from both the sides and we are left with I is equal to 60 degrees, which is the angle of incidence. Question number 2. The refractive index of dense flint glass is 1.65 and that of alcohol is 1.36, both with respect to air. What is the refractive index of flint glass with respect to alcohol? So here they have given us refractive index of flint glass and of alcohol. So therefore, what are we going to do? We just have to calculate by using Snell's law. So after you calculate it, you will get 1.21. Next topic, we come with spherical lens. Now this is till now we were studying about the mirror. Now we are going to see what is spherical lens. It is an optical lens with a curved surface that causes light rays to converge or diverge. Now for convex, if you see, how does it look like? It is thick at the middle and it is about converging lens, and concave, it is thin at the middle and it is diverging. So a concave lens is thin in the middle and convex lens has a thicker middle and thinner edges. So it makes the light converge. certain terms which are used in spherical lens, which we have seen it in the previous slides also, so that will help you to understand these terms much easier. First is center of curvature. For a spherical lens is the point on the principal axis, and that is at the same distance from the lens as the radius of curvature. Next we have principal axis. This is an imaginary straight line which is passing through the two center of curvature of lens. It is called principal axis. Second, we have principal focus. Now, what is principal focus? It's the point where parallel rays they meet. In the bracket, if you see, we have mentioned convex lens or appear to diverge from concave lens, and lenses have two such points. Finally, we have aperture, which we have discussed in the previous slides. The aperture of a spherical lens is its effective diameter, which represents the size of the circular outline. Optical center, the optical center of a lens is where light passes through without bending, which you have to remember. Then you have a focal length. It is the distance between the principal focus and the optical center. Certain ray diagrams, which you see it on the screen, rays parallel to the principal axis, they converge at the principal focus after refraction in a convex lens, while they appear to diverge from the principal focus in a concave lens. So looking at the diagram, you can even draw the diagrams in your notebook, and that will be more helpful to you for your exams. Further, we see more diagrams here. A ray passing through or directed to the focus will emerge parallel to the principal axis. Then the last one, a ray directed towards the optical center will emerge without deviation, as we have also studied in the previous slides that how it remains undeviated. Certain image formation by convex lens. First, case 1, if you see, it is object is at infinity. We don't know where the object is, so that is at infinity. Case 2, object at beyond 2f. You see it on the screen. Then the third one is object at 2f, and fourth case is object is between f and 2f. So you have to learn it, that where the object is and how the image formation looks like. Further, we have case 5 where object is at f, that's focal length, and here object distance, which is less than f. So request students that you draw all these diagrams in your notebook, please. Further, if we go, we find the image formation by concave lens. Now here you find the object is at infinity, and the second diagram tells you between infinity and optical center of the lens. So these two diagrams also you can draw in your notebook. Coming to the formulas here, we have a lens formula and magnification. 1 upon f is equal to 1 upon v minus 1 upon u. Once again, what is u? That is image distance. What is v? That is object distance, and f is your focal length. So what's your formula? 1 upon f is equal to 1 upon v minus 1 upon u. So to apply this, we apply these sign conventions, which is very similar to those which are used for spherical mirrors, with the exception that all measurements are taken from the optical center of the lens. Coming back to the topic, that is magnification. Now the ratio of the height of the image and the height of the object is represented by small m, which we have done it in the previous slide, but just for your revision we can take this again, that magnification is equal to hi upon ho. Now what is that? Hi, it is the height of the image. What is ho? It is the height of the object, which is equal to v upon u. Now this point, if you see, the bracket I have put here is extremely important. Negative sign shows that image is virtual and erect, and positive sign shows that the image is real and inverted. Okay, let's go further and understand what is power of lens. Okay, just erase this. Here we go. So the power of a lens is a measure of its ability to converge or diverge light and is defined as the reciprocal of its focal length in meters. Now, when we are talking about the length, we are talking about meters. So it is typically measured in diopter. I'll repeat this again. It is measured in what? Diopter, and is calculated using the formula P is equal to 1 upon f. So what is f, students? That is focal length in meter. And what is the SI unit? It is diopter, denoted by capital D. Now power, when we talk about, you can please note this down. I'm putting a slide star over here to understand that yes, this is extremely important. Power for convex lens, focal length is positive, and when we talk about power for concave lens, the F, that is focal length, is negative. Likewise, we have the second question. Object is placed at the focus of a convex lens. So you have to draw a ray diagram to locate the position of the image formed, and if any, state its position and nature. So now if you see here the ray diagram, you can even note it down in your notebook. Image is formed where? It is at infinity. An image will be real, inverted and enlarged. Next question is, what is meant by power of a lens, which I have already discussed in the previous slide. Next question is, differentiate between reflection and refraction of light. Continuing with the question, you name the spherical mirror which is used for shaving, which is used as. So it is used as what? As a shaving mirror, rear view mirror in vehicles, reflector in search fights. So you can write any of the uses which is related to spherical mirror. So there are three differences between real and virtual image, which that you can see it on the screen. That also you can learn it and then jot it down in your notebook. If we say about the real image, it can be taken on a screen. Virtual image, it cannot be taken on a screen. Real image, it is always inverted, and for virtual image, it is always erected. And for real image, third point, when reflected or refracted rays actually meet at a point, then real image is formed. And for virtual image, when reflected or refracted rays, they appear to meet at a point, then virtual image is formed. Further, we see the question, a 2 centimeter tall object is placed perpendicular to the principal axis of a convex lens of one focal length 10 centimeter. The distance of the object from the lens is 15 centimeter. Find the position, nature and size of the image formed. So first thing we have to see which lens it is. It is convex lens. And what is given? It is H1, we can name it as, it is 2 centimeter. Then we have F, which is focal length 10 centimeter, U is minus 15 centimeter, and we have to find what? We have to find the position, nature and size of the image. So we have to find V here. Again, we have to use which formula? Lens formula, because we are talking about convex lens. So what is the formula? 1 upon V minus 1 upon U is equal to 1 upon F. Students, again, I want to remind you that please see to it that all the sign conventions you are very, very clear while solving these questions. Likewise, you substitute the values and then you will get the answer minus 4 centimeter. So that means image is real, inverted, and it is 4 times enlarged. Likewise, I have one more question. A concave mirror produces a 3 times enlarged image of an object placed 10 centimeter in front of it. Calculate the focal length of the mirror. Show the formation of the image with the help of a ray diagram, and the object is placed 6 centimeter from the pole of a convex mirror. So before solving the question, first you have to see to it that what is the object, like whether it's a lens or it is a mirror. Now here we could use the mirror formula for this. That is why it is mentioned there that it is a concave mirror. So U is minus 10 centimeter. So let a real image which is formed in concave mirror, that is M is equal to minus V upon U. Now magnification, if you see, that is minus 3. So V is equal to 3 into U. So we cross multiply, and 10 centimeter is your U, which is given. and you multiply, you will get 30 centimeter. So all these values you have to put it in the mirror formula. See to it that you are calculating it properly without making any mistake related to the signs. Second part is about you have to draw the ray diagram, which is object is placed 6 centimeter away from the pole of a convex mirror. So when u is equal to minus 6 centimeter from the pole of a convex mirror, the image will be virtual, erected and smaller. Going further, that is your competency based question that will also help you to understand in detail the concept of reflection of light. Now this is the question given, which is rear view mirror is a device that allows the driver to see the traffic on the road behind him. It usually finds its place at the top of the windscreen inside the cabin. This device is one of the most basic but essential safety devices in the vehicle. It provides assistance to the driver during overtaking, parking in reverse gear. Generally, vehicles also have a pair of mirrors attached to the body from the outside. They are known as side mirrors or outer rear view mirrors, which is abbreviated as ORVM, which serve the same purpose. Almost all modern cars mount their side mirrors on the doors, normally at a pillar rather than the wings. So let's see this. The type of questions, that what type of mirror is required to make ORVM in the vehicle. The second is what type of image is formed by such a mirror. So the answer for the first one, A, is convex mirror. What type of image is formed here? It forms an erect, virtual and diminished image for all positions of the object placed in front of it. C part, they have asked us the ray diagram. So look at this ray diagram, the formation of the image by this type of mirror. Which mirror? That's a convex mirror. And why are these types of mirrors used as rear view mirrors? So you can write your answer in this form. Convex mirrors are used as rear view mirrors in vehicles to see the traffic at the rear side. That means what? Back side, because a convex mirror always produces an erect image of the object. Point number 2, the image formed in a convex mirror is highly diminished, due to which a convex mirror gives a wide field of view. Students, there's one more question attached to the slide, which you can request if you want to try this of your own. So likewise, there are more questions which are being there attached. So you can please practice one more question, and that will help you to understand the concept. Answers are also given along with, and I'm sure these topics and the guidelines and the outlines which are being given to you for this topic is helpful to you. And very soon you will find the other chapters of physics, chemistry and maths will be there in the YouTube, and you can work upon it, and sure would love to know your feedbacks and comments. So thank you so much and have a great day.